Now we are going to look at 1.4, combining like terms. First, let's look at what like terms are. You can only add things that are alike to each other. So we can add x's to x's. So I have an x here. Do you see any other x's? Right there. Okay, I have some constants. I have a 5 and a 12. Constants are like terms. And then I have this minus 2y, which is all by itself. There's no like terms there. So I can put the x's together. 3 minus 6 is negative 3x. We generally put these in alphabetical order with the constant last. So I'm going to put the minus 2y next. And then I'll do 5 plus 12 is 17. There's no equal sign here, so I can't solve for a variable. I can just simplify the expression. When there's no equal sign, it's an expression, and all you can do is simplify. So let's look at number 2. It's also an expression with no equal sign. The x's are like terms. The constants are like terms. So now I can combine. 5x and 3x is 8x. 4 minus 2 is 2. That's all I can do. That's as simplified as that expression will get. So now let's look at when there is an equal sign, and we're going to solve them. If your like terms are on the same side of the equal sign, you can put them together. You don't do the opposite because you're not eliminating, you're combining. This is an imaginary 1, 1x, and 3x is 4x. Now bring down your 5. Bring down everything else because there are no like terms on this side of the equal sign, so I can't combine anything. Now it's just like what we did but on 1.3. It's variables on both sides. We're going to get rid of a variable, and we're going to get 2x plus 5 equals negative 11. Now it's a two-step, so we take away the 5. 2x equals negative 16. And I divide by 2, x equals negative 8. All right, we're not going to check this one, but we go over here. I hope I'm not getting fuzzy. A little fuzzy. Okay, on this one, do I have like terms on this side of the inequality, the symbol? Yes, I have an x and another x. Well, that's like 1x and 1x. That's 2x minus 3. Bring down the minus 3 equals negative 3. Well, now I just have a two-step. And to get x alone, I need to get rid of this. But when I get rid of that, it also gets rid of this. So I have 2x equals 0. 0 to, whoops, this was a less than or equal to, not as equal. 0 divided by anything is still 0. It is okay to have 0 as an answer. That's my answer. So the last one, I want to show you a slightly different approach that some of you might like better. It's kind of a shortcut, but it works. It's a different way of looking at it. What if we think of it as I want all the x's on this side, and I apologize that all these numbers are in the way, and all the numbers, the constants on this side. Well, this variable, this x, is already on the x side. These two are not. They're on the number side. If I want to move them across an equal sign to the x side, I have to do the opposite. Isn't that how I eliminate and get rid of those, to do the inverse operation? So the opposite of 2x is minus 2x. The opposite of 3x is minus 3x. Now all the x's are where they're supposed to be. This minus 6 is on the number side, but this 22 is not, and this negative 4 are not. So to jump across the equal sign, to get rid of it here and put it over here, it has to go minus 22. Minus 4 becomes plus 4. So basically, I did all the inverse operations in one step. Some people like to look at it this way better. It makes more sense to their brains. I don't care which way you do it, whatever makes more sense to you in your head. Negative 3 minus 2 minus 3 is negative 8x. All you're doing now is combining. Negative 6 minus 22 plus 4 is negative 24. And then you're ready for your last step, which is divide. always divide by exactly what's there by my -8, and I get that x equals 3.